let's look at what we call the ambiguous case, okay? Sometimes whenever you're given, or whenever you're given side angle, okay? Whenever you go through and you solve and try to find the sides and the angle measures of your triangle, sometimes you'll get one triangle. Sometimes you can come out with two possible triangles that fit what they give you. Two triangles. And sometimes at what they give you with side angle, you get no such triangle. No such triangle. Now, I have it outlined in your notes, and you have it in the book, you know, how this ambiguous case works and so forth. For your purposes in this class, you're not really going to need to worry about, you know, what we have in the notes as far as that goes. You're just going to say, okay, if I see side angle, I'm going to have to look out for the ambiguous case, and you pretty much treat them the same way, okay? All right, now, when do you look out for the ambiguous case? When you have side angle. What is this spelled backwards? So it's going to be a problem, right? All right, so before we get into an example with side angle, let's go back to whenever we're solving equations like sine of x is equal to 1/2, okay? And we had to solve for x. We could say x is the angle whose sine is 1/2, right? And when we thought about the unit circle, here's what we thought about. Where do I have an angle whose sine is 1/2? Well, I have that here at pi over 6, or 30 degrees, right? Because this is the point, what? Square root of 3 over 2 comma 1/2, and my sine is 1/2. But we also had that at a reference angle of 30 degrees right here. We also had, what, a sine that was 1/2, didn't we? All right, so we had two such angles, right? 30 degrees and then this angle, right? So x was equal to 30 degrees here, and x was equal to 180 minus 30, or 150 degrees, right? Keep that in mind. And we're about to work a problem here. All right, let's suppose that we're given this. Solve the triangle or triangles. Solve the triangle or triangles. Let's see, round side and angle measures to 1 decimal place. Part A, we have lowercase a is equal to 3, lowercase b is equal to 1, and capital B is equal to 17 degrees, okay? Now, I'm going to draw some kind of triangle here, just for reference, okay? I don't care about if it's an accurate triangle, if it's going to be an obtuse one, or an acute one, or whatever. I'm just going to draw some old triangle here, okay? Now, I like the side that I'm given, or the angle I'm given the measure of, I like to put that right here. So I'm going to call that angle B. So this is side B, which is 1. And then, I don't know, maybe I'll call this side A, which is 3. So that's angle A. So this is angle C, and that's side C. All right, notice what I'm given. I'm given side, angle, right? Side, angle. I'm given two sides and an angle opposite one of those sides. So what does this spell backwards? So it's going to be a problem. So what do I mean by it's going to be a problem? We could have one triangle, we could have two triangles, or we could have 0 triangles, right? But either way, I still do the math the same way. All right, so let's start out using the law of sines and find what we can find. If I'm given this measure of an angle and that side, I'm going to start out with that. I'm going to say sine of 17 degrees over 1 is equal to the sine of angle A over 3. So I'm going to say sine of 17 degrees over 1 is equal to the sine of angle A over 3. And if I cross multiply, I get sine of A is equal to 3 times sine of 17 degrees. Now, how do we solve for A right here? We just solved for X a minute ago. We would say A is equal to the angle whose sine is 3 times the sine of 17 degrees. So let me see, if I calculate this, put it in my calculator, I get 61.3 degrees. 61.3 degrees. All right, so what is that then? Think about your unit circle, what we just found here. What did we just find? We just found the angle in quadrant 1 to be 61.3 degrees, whose sine was this stuff, okay? But we also have what? An angle over here in quadrant 2 with a reference angle of 61.3 degrees, right? So we're saying that A could be 61.3 degrees, could be this angle, but A could also be this angle. So A could be 180 back off 61.3. So let's put that. Or A could be equal to 180 minus 61.3. Good, good. I'm still in the shot then. So I get 118.7. And let's go ahead and put degrees here and here. All right, so what are we saying? We're saying that A could be that or A could be that, right? We just don't know because both of those values have a sine that is this stuff, 3 times the sine of 17. All right, so what I'm going to do is I'm going to look at this as being two different triangles. I'm going to say triangle 1 and triangle 2. Triangle 2. All right, so let's start out with triangle 1. And for triangle 1, we're going to say A is approximately 61.3 degrees. A is approximately 61.3 degrees. So if this is 61.3 degrees, I need to find what next? C, and then lowercase c. So how do I find capital C? I say that's 180 total degrees in a triangle minus 17 degrees minus 61.3 degrees. Minus 61.3 degrees. Oh, I feel like being lazy here. So I got C is approximately 101.7 degrees. So I got like 101.7 degrees. All right, what about side C? I'll say the sine of 101.7 over C is equal to sine of 17 over 1 using the law of sines. So the sine of 101.7 degrees over side C is equal to the sine of B, 17 degrees, over the length of side B, which is 1. Then we'll get C is equal to, what do we have? Sine of 101.7 degrees over sine of 17 degrees. And if you go ahead and do that calculation, you'll get C is approximately, let me erase some stuff here so I have room for it, 3.3. All right, so that's the first triangle. I have that stuff. What about the second possible triangle? What did we say? A could be 61.3 or A could be what? What do we have over there? We had 118.7, right? So A could be 118.7 degrees, we said, right? So let's find, tell you what. So if A is 118.7 is greater than 90, so it's going to be an obtuse angle, right? Angle A is going to look something like this. That's angle A. And what else do we have here? We called this B, which was 17 degrees. We said 1 was opposite of it. We said this was 3. And I think that's all we had. C and C, right? So if A is 118.7 degrees, how do I find angle C? Angle C will be 180 degrees minus 17 degrees minus 118.7. Minus 17 degrees minus 118.7 degrees. And if we calculate this, what do we get for C? We get 44.3 degrees. So we get 44.3 degrees. Then we need to find side C. So we could use our law of sines. So I'm going to say the sine of 44.3 degrees, 44.3 degrees over C is equal to the sine of 17 degrees over 1. Alright, so if you do all this math and so forth and you solve, you get C is approximately 2.4 right here, okay? So we have two possible triangles that could exist. So let me put my answer over here. Let me say, for two triangles exist, and we can say for triangle 1, let me write it nice and neat. Capital A is 61.3 degrees. Capital C is approximately 101.7 degrees. And what was lowercase c? Approximately 3.3, whatever the unit was. And then let's list our stuff for triangle 2. Triangle 2. What do we have for triangle 2? A is approximately 118.7 degrees. I guess technically that should be approximate. What is C? C is approximately 44.3 degrees, and lowercase c is approximately what? 2.4. That's the case where two triangles exist in an ambiguous case.